Welcome to the ET380AM amplitude modulation receivers. Here's a block diagram of our receiver basic function. So we need a collector, an antenna to collect the signals, a selector, a tuned resonant circuits to select the desired station and block others. A detector is a demodulator state to detect the intelligence on the carrier. A reproducer is a device to display or reproduce the intelligence signal. AM receivers must have these characteristics. Amplifiers must be sensitive enough to amplify the weak RF signals on the antenna. They must have tuned resonant circuits selective enough to pass only the desired station. This characteristic is called selectivity. The higher the received frequency, the more difficult it is to design highly selective circuits. AM receivers need proper detector circuitry to demodulate the desired signal. They need proper output circuitry to process and make sense out of the received signals. Here's a block diagram of a basic AM receiver. We have the RF amplifier, the mixer, and the local oscillator. These are all gang tuned. Then we have one or more IF amplifier sections, intermediate frequency. We need a detector, audio voltage amplifier, and an audio power amplifier out to our speaker. For a standard AM receiver, the super heterodyne receiver uses fixed tuning on all the RF amplifier stages and to 455 kilohertz. The AM band is from 535 to 1605 kilohertz, so it's extremely wide. The boxed area in the mixer stage where RF and local oscillator frequencies are mixed. It is important to note that all three boxes are gang tuned. The output of the mixer stage is the difference frequency between the RF signal and the local oscillator. It stays constant at 455 kilohertz because of gang tuning. The 450 kilohertz output is called the intermediate frequency. All receivers will have an IF frequency. The W stages can now be tuned to amplify a very narrow bandwidth of 455 kilohertz. This is what makes a modern radio so cheap and easy to use. Here is a block diagram of a basic AM receiver made by Elanco. It is a kit that you could buy and build an AM FM receiver. And it has an AM mixer, an oscillator, first IF, AM IF amplifier, second IF amplifier, AM detector, audio frequency control, and an audio amplifier. Here's a circuit of a simple AM receiver circuit. It's a diode type. So the diode detector and capacitor low pass filter make this an AM receiver. The stations detected are determined by the antenna and the resonant circuit. The type of intelligent reproduce will be audio, and no power supply is needed. Here's a real circuit from a Elanco AM radio, and this is a detector and auto gain control. And we pick up our modulated signal with intelligence from here, goes through the diode, which blocks half of it. Then we filter out the modulated signal, and we're going to get the audio signal out. Detector and auto gain control. The purpose of the detector is to change the amplitude modulated IF signal back to an audio signal. This process is called detection or demodulation. First, the amplitude modulated IF signal is applied to the diode in such a way as to leave only the negative portion of the signal. The frequency of 455 kilohertz, and is designed only to leave that frequency of 455. The purpose of the automatic gain control circuit is to maintain a constant level at the detector regardless of the strength of the incoming signal. The mixer stage and local oscillator convert the desired RF to a lower frequency. A mixer is a nonlinear resistance device where two frequencies are mixed. A mixer has two inputs. The mixer inputs are the desired RF signal with modulation and the local oscillator frequency, a sine wave. An amplifier diode can be used for a mixer stage. Amplifiers can be designed for bipolar transistor, FETs, or dual gate MOSFETs, and integrated circuits. At UHF and above, the special diodes are used as mixers to minimize internal noise. Mixers produce more noise than any other stage in the receiver. There is little or no gain in the mixer stage. A mixer has one output terminal with 4 frequencies come out: the original RF, the local oscillator frequency, the sum of the RF and local oscillator frequency, and the difference frequency between the RF and the local oscillator frequency. All output frequencies except the local oscillator contain sideband frequencies. Intermediate frequency or IF amplifiers. Right in here, the intermediate frequency IF amplifier provides most of the receiver gain and selectivity. IF amplifier tuned to one fixed frequency, and that is the difference frequency output of the mixer. Receivers have several IF amp stages for high gain. IF amplifiers use high Q resonant transformers enabled to couple between the stages for high selectivity. Transformers are sometimes stagger tuned to produce a near perfect bandpass. Receiver gain and selectivity performance is primarily dependent on IF stages called IF strip. Here's the first AM intermediate frequency amplifier from our Elanco radio. And we have a transistor, and we have our transformers we talked about that are adjustable. And in our radio there are 3 types, not including our oscillator, and they come in different colors on the plug on the top, and these are adjustable. First, AM intermediate frequency amplifier. The purpose is to increase the amplitude of the intermediate frequency and provide selectivity. Selectivity is the ability to pick out one radio station while rejecting all others. The gain of the first IF amplifier decreases after the automatic gain control threshold is passed. This keeps the audio output constant at the detector and prevents overload at the second IF amp. Here we show the frequency response of the IF transformers. We have the ideal response, typical response of one tank circuit, stagger tuned stages, and the resultant response curve and the desired bandwidth. Here's an actual curve of our IF, and we're showing the 455 kilohertz center and our bandwidth here. Here's an actual circuit from our Elanco AM radio, and we're showing a transistor and our black transformer. The second intermediate frequency amplifier, the second IF transformer T8, acts as a bandpass filter with a 3 dB bandwidth of approximately 6 kilohertz. Both IF amplifiers are tuned to a frequency of 455 kilohertz and only need to be aligned once when the radio is built. And this is done by adjusting the screw at the top of the transformer. Here's a schematic of our audio amplifier in our Elanco radio. Here we have Q10 transistor. This one's operating at class A. And these Darlington pairs are a class AB. And at low levels, we operate at a class A. As the levels increase, we start operating at a class AB, which is not as clear as the class A's, but it is more energy efficient.